On this next set of problems, it says to solve the following quadratic equations using factoring. Now notice all the ones that we just completed were just factoring problems, meaning it started as an expression, no equal sign, and ended as a factored expression, again no equal sign. This one starts with an equal sign, and although we are going to factor it in the middle of the problem, the solution to an equals problem is like a solution, like x equals something at the end, okay? So don't just stop at the factoring, nor on the previous section, I don't want you setting them equal to 0 and solving. That wouldn't make sense either, since there was no equals on this one, on the previous section. So on this one, I need to first set it equal to 0. So we have 3x squared plus x minus 10 equals 0. Then I have to factor. Again, there's no GCF. 2, 3, or 4 terms. There's 3. This one is a hard trinomial. I'm not going to go ahead and do all of them. I'm just going to use the guess and check method just to see. I think I'm going to switch those two around. See if I can't get this quickly here. If you want to use the other method, go ahead. I'm trying to use two different signs to get to a positive one, so that's a negative on the 5, positive on the 6. So this factors into 3x minus 5 and x plus 2. And if you want to group, then go ahead and use the other method. You're still going to get the same factors, even if you use the other method. So now I'm going to use a zero product property, which says either the first factor is 0 or the second factor is 0. And then I can solve each one of those. So I'm going to add 5 to both sides and get 3x equals 5 and x equals 5/3. Notice that this is a very different answer than the section that just said factor. Don't mix up the two sections, okay? So you can either leave your answer x equals positive 5/3 and x equals 2, or the more appropriate way of writing it would be negative 2 comma 5/3 in the braces, which means this is the solution inside here. On the next problem, it's not equal to 0 yet here either. I would prefer to move the 243x to the other side. The reason I would prefer to move the 243 instead of the 81 is because the 81x squared, the x squared term, is already positive, and I like my first term to be positive, so I'm going to leave him on the right side and make him positive. There is a GCF. The GCF here is 81 because both 243 and 81 can be divided by 81, and they both can be divided by x. So that leaves me 1x minus 3. Now this is completely factored. A lot of students get to this point and they're like, well, now what do I do? Well, this is already factored. You have a factor 81x and you have the second factor x minus 3. So you're just going to set each factor equal to 0. I don't know why, but this one was supposed to be one of the easier ones, but a lot of students make mistakes on this one because they think they have to make it harder than necessary. But you just, the 81x is a factor and the x minus 3 is a factor, set them equal to 0 and solve, and you get your two answers, 0 and 3. Okay, number 21 is a little bit more difficult because the left side looked like it already factored. And a lot of students are like, oh yay, it's already half done for me. No, it's not. Because it's not equal to 0, I have to do a lot of distributing before I can move the 8 over to make it equal to 0. So there's a lot of work here to be done first. So we have x squared minus 2x plus 5x minus 10 equals 8. At this point now I can subtract 8 from both sides, which gets me x squared plus 3x minus 18 equals 0. So now I'm going to factor x squared plus 3x minus 18 equals 0. It's a, let's see, 3 terms. There is no GCF, and because it's a 3 terms and the leading coefficient is 1, that tells me that I can, it's an easy trinomial. So I have x and x. I am looking for two numbers that multiply to 18, negative 18, and add to 3. So let's see, 18, I have 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, and 6 is already on my list. Which one of these, with one of each sign, that's what the negative on the 18 says, it's one of each sign, can add to 3? Well, it looks like 3 and 6. In order to get to a positive 3, this positive sign has to go with a bigger value, which is 6, and that means the other one has to be negative. So I set x minus 3 equal to 0, x plus 6 equal to 0. I can solve each of these. Which gets me x is equal to 3 and x is equal to negative 6. Excellent. On our next set of problems, we have word problems, which means I have to set up the problem, solve the equation, answer the question, put units in your answer, and then make sure that you write what each variable represents and show your work. So you're going to be getting points all along the way here. So for number 22, it says one number is 3 less than 5 times another. The product of the two numbers is 36. What are the numbers? So the first thing I'm trying to identify is, what is it that I don't know? Well, usually in the last sentence or question, it tells you what you don't know. It gives you a directive or asks you a question. In this case, I don't know what the numbers are. So I'm going to go ahead and let x equal my first number. And then I'm going to figure out what the heck the second number is too. But I got to reread again, okay? Because I didn't get all of that stuff in one piece. So I'm going to go back and look for what we call the comparative statement. So the comparative statement is where one number is being compared to the other. So in the first sentence it says one number is 3 less than 5 times another. So that is comparing one to the other. So I can say that the second number is 3 less than 5 times the other. So if the other is x, so I take 5 times the x less 3. Remember what than does? Than switches the order. So the 5x is going to go in front and the less 3 goes in the back. Now I have the product of two numbers is 36. So I'm going to take the first number and the second number and I'm going to multiply them to get 36. So the second statement right here is the statement where you're going to write your equation. I'm taking the two numbers, x and 5x plus 3, minus 3. I'm going to multiply them because that's what product means. Product means multiply. And the equation is equal to 36. So this right here is your equation, and that's going to get you about almost half your points here, just being able to tell me what the x's are and then saying that they multiplied equal to x. The rest of the points are going to be got if you can solve. So 5x times x is 5x squared. X times 3 is minus 3x equals 36. I'm going to subtract 36 from both sides. And that gets me 5x squared minus 3x minus 36 equals 0. At this point, I need to factor. Doesn't look like there's a GCF at all. So you can factor any way you want to. This looks like, because there's no GCF and it's a trinomial, it's a hard trinomial, you can either guess and check or grouping. Due to space here, I'm going to go ahead and guess and check. So my choices for 5 are 1x times 5x. The choices for 36, there's a lot of choices. I'm going to write them over here. 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 doesn't work, but 6 and 6 does. Okay, so let's see. If I try 1x and 5x, let's see. 6 and 6, that's going to get me 30 and 6. That doesn't add to negative 3. That's too big. So let's see. Let's try 4 and 9. So that's 20 and 9. Okay, that subtracts and gets 11. That's closer to 3. If I switch them around, the values are just going to get much bigger, so that's not going to work. Let's try the next one. 3 and 12. So when I cross multiply, I'm getting 15x and 12x, and that will get me my negative 3. I put this negative from the 3 on the larger product. The product is 15. Notice I'm putting it on the product, not the 3 and the 12. I'm not comparing which one's bigger, the 3 or the 12. I'm saying which one's bigger, the 15 or the 12. So the 15 is bigger, so that's the one that gets the minus. So this factors into x minus 3, 5x plus 12. Then I can set each of those factors equal to 0. So I'm getting x is equal to 3 and negative 12/5. Okay, now both of these are x values. Do you remember what x values are? The x value, we wrote it over here, is the first number. So let's say the first number is x equals 3. Well, what would be the second number? The second number, we would have to find that by plugging in 5 times x minus 3. Who's the x? 3. So that's 15 minus 3, which is 12. So 3 and 12 are one pair of numbers that work, where one number is 3 less than 5 times the other, so 3 times 5 is 15, less 3 is 12, and they product when you multiply them to get to 36. Now that's not the only pair of numbers, because when we use, let's say the first number, x is equal to negative 12/5, to get the second number, I would have to plug in 5 times negative 12/5 minus 3, which gets me, let's see, the 5's divide out nicely, and negative 12 minus 3, which is negative 15. So apparently, negative 12/5 and negative 15 are another pair of numbers in which if you multiplied it by 5 and subtracted 3, you would get the other term. So one number is 3 less than 5 times the other. And if you multiplied these two together, you would get positive 36. So there's two sets of correct solutions.